Hello, I'm Ethan Hines, and this is
Jackson A.
And this is take 2 of the chemistry project due to some complications against this man. If you would like to take a moment to speak on that.
Yeah, the underwear allegations, I know Mr. Woodland and administration, I sincerely apologize for the inconvenience and to take the time out of the day, and we promise we're all suited up for this project.
Yep, suit and tie and cologne, the whole 9 yards. You know how it goes.
Very classy.
Yeah, and we just hope you enjoy the video, and hopefully this is a better take for you. And
Yep.
Shout out to what's the young fella's name in the comments?
Treacherous Green.
Treacherous Gump. There
Yep.
it is. Yep.
Treacherous Green.
Shout out to him. All right.
Thank you.
Yep.
Alright, so we'll be explaining limiting and excess reagents. So we have the problem here. What is the mass of magnesium oxide is produced from the reaction of 15 grams of magnesium and 12 grams of oxygen? So for the first step here, we got the equation, and we need to balance the equation. So we got Mg plus O2. The O2 is there because it's a hydrogen hydrogen, and then that's MgO. So we gotta balance it out here. Put 2 oxygens, 2 magnesium, put the 2 there. Alright, so that's the first step of the equation. Looking good.
Yep.
So we'll start off by finding the moles of magnesium. So we'll do mass over molar mass. And then, so it's 15 over, thank you. Looking snazzy today now. Sorry for the underwear allegations.
These are shorts, by the way.
Yeah.
Shorts, yep.
And 0.617 moles is what comes out of this. So for the next step of the problem, we got to find the moles of the want. And that is the moles of magnesium oxide equals the moles of magnesium times the mole ratio.
Yep. That's
Mole
correct,
ratio. And then, so that's 0.617 times 1, which is 0.617 moles. And that's the moles of magnesium oxide. And then, what we do here, we got to find the mass of our want, which is mass equals moles times molar mass. So your equation here, 0.617 times 40.31 is 24.9 grams. 24.9 grams.
Correct. Very correct.
Very.
Actually.
Did the calculations and everything. So for the next step of the problem, we got to see which is the limiting or excess reagent. And if O2 is the limiting reagent, is what we're doing now. So first step of the equation is already done. We got everything balanced. So we'll go to step 2. Thank you. Looking good. Nice tie.
Thanks. Yep.
So first we'll do what we did on this side. We'll find the moles of O2. It's 12, the mass times divided by the molar mass, which is 12 divided by 32,
yep.
And that's 0.375 moles. So now we've got to find the moles of our want, and that is magnesium oxide. The moles of magnesium oxide equals the moles of O2, which is 0 times the mole ratio. Mole ratio. So then that's 0.375 times 2, which is 2 over 1. And that'll give us 0.75 moles. Now, what we're gonna do here, we're gonna find the mass of our want if you're using oxygen. Oxygen. So 0.75 times 40.31, that's 30.2 grams. 30.2 grams.
Correct. Yep.
That's right. And we also know this is a limiting and excess reagent question because there is we have information about 2 reactants in the problem. 2 reactants in the problem, so we got information. That's how we know it's a limiting and excess reagent question. Alright, so, thank you. So, magnesium is the limiting reagent in this problem because, and the limiting reagent is the reactant that controls the amount of product that can be formed. It's the reactant that gets used up first in the reaction. And O2 is the excess reagent because it's not entirely consumed in the reaction. There's more of the excess reactant that is needed to react with the limiting reagent. So say you have 3 pieces of bread, 2 slices of cheese, and 1 piece of meat. The meat is the limiting reagent because it limits how many sandwiches you can make. And then for the bread and cheese are excess reagents because there's more than enough to use with the limiting amount of meat.
Yeah, that's highly correct.
That is, I think that's right,
Yeah,
and
that's good.
that is how you do limiting and excess reagent problems.
Yep.
Right?
Now we will be discussing percent yield. Thank you, sir. If 26.5 was found in the lab and the theoretical is 24.9 grams, what is the percent yield? So you got percent yield equals actual over theoretical times 100. So, hold this for me.
Yep, here we go.
So, actual, so percent yield equals 26 OP over 24.9 grams, which is, this is your theoretical and this is what you found in the lab, times 100. Calculator, sir.
Yep, that should give you 104%.
So that equals 104% yield.
Yep, that's your percent yield.
That's your percent yield right there, as we can see on the board.
Yep.
Cut the camera now, please.
Alright.
The yield is 104% because what was found in the lab is more than what it is supposed to be. So something must have went wrong in the lab. Not by a lot, just something little causing the mass in the lab to be higher than the theoretical.
Yep, that's correct.
That's correct.
Thank
Yep,
you.
Very correct.
Thank you for your time.
Yep, thank you.
Alright, thank you for watching our video. I'm Jackson E.
I'm Ethan Hines. That's our video on the take 2 of the chemistry project.
Limiting and excess reagents.
And percent yield.
Yep, thank you, administration of Mr. Woodland, for giving us the second opportunity to do this.
And we really appreciate that.
Let's
And
go Oilers.
Yep, there we go.
Let's go.